Okay, we've definitely enhanced our game. Now that we've got some really nice screens in place for starting, winning, and losing, let's take the next step. And how about putting in a background that scrolls? I think that would be a very good next step.
It would. You know, there's that whole ongoing thing, though. When if you're in space, can you imagine how fast you have to be going to actually see scrolling stars?
Boy, yeah, you're moving.
The game would technically be unplayable.
But how many games do you find at the arcade that have scrolling stars in the background?
It's a standard.
It is.
I blame Star Trek.
Now, there are a lot of ways that we can go about implementing a scrolling background. We're going to take one of the easiest and cheapest ways we possibly can. All we're going to do is simply create two planes, have the planes scroll down the screen, and as one of the planes gets off the screen, it's simply going to snap itself back to the top. And that's going to give us the illusion that we are looking for. Again, the idea of these videos are to present the creation of a simple game, and now a simple/polished game, in the most simplistic way we possibly can, so that those that are following along that have never touched Unity before and perhaps their programming skills are still a bit lacking shouldn't have much trouble understanding what we're doing.
Yeah, well, conceptually, I already see what you're going to do. So.
Okay, outstanding. So the first thing I'm going to do is kick things off by creating a plane that we can apply our texture that we'll bring in just a second too. So let's go ahead and come up here to our game object, come down to create other, and then we're going to grab a plane. Let's go ahead and set the name of this guy. So stars. That looks pretty creative. Now, with that in place, there's a few numbers I'd like to set for position. So let's go ahead and zero it out in X. In Y, we'll set this to a value of 1. And over here in Z, I'm going to push him back. We're going to rotate him in just a second. Actually, let's go ahead and do that now.
Okay.
I'm going to bring him all the way around 270, so he's looking right at us. But I want to push him back a little. If we were to come in here and take a look at the scene, you can see how some of our objects are just kind of penetrating through. So let's go back, I don't know, maybe, and it really doesn't matter. We can go back 100 units if we want, because again, this is an orthographic camera.
Yeah, there's no sense of depth.
So we're just going to push them back about 3.25.
Is there any particular reason why you didn't just set the rotation to -90?
We very well could do that. And that works fine. You'll find later that the number by Unity will get changed to 270 for whatever reason.
Okay.
So I just went ahead and stuck with 270.
No, it makes sense.
Okay, so now that we have this in place, let's go ahead and scale them up. And we'll go with 1.35 for our scale. And of course, we don't have to do this all the way across the board, just only on X and Z, but we will. So there we are, filling out the entire screen that we're using. So we've got them rotated, we've got them positioned. At this point, we need some sort of material to apply to them. So let's go ahead and scroll up to Materials and right-click, and let's create a new material. Let's give this guy a name real quick. So M_stars. Now we need to apply it, so let's just simply drag and drop him up here. So you'll see that he is using M_stars in our renderer. Now that we have that set up, we can bring in the texture real quick. Now, let me point this out. We've got two textures. We've got our stars texture, and we have our stars_large texture. I'm going to bring in the stars_large. They have been created specifically for the training video, meaning the stars are larger than you would want them normally.
Yeah.
They look a little odd, but seeing how we are recording and then encoding, and during the encoding process we are shrinking the videos down, the last thing we'd like to see would be for the stars to completely vanish.
So if you're watching this like on the website scaled down, it might still be a little hard to see.
That's true. So let's go ahead and bring our stars large in. So I'm going to simply, from off screen, drag and scroll down, drop. And once again, with this guy, let's go ahead and come over here, and we do not need any maps, so we'll go ahead and apply that. So we have our texture in, we have a material, but I'm not going to assign the material yet, just because with this guy being bright white, it'll be very easy to see him moving down and then snapping back up.
Sure.
Because I'm not going to create both of the planes right now. I'm just going to create one and get them completely finished. Then all I have to do is duplicate them, move them up, and the whole thing's done. So it's very quick.
Nice.
So I'm going to jump back over into Visual Studio. Let's create a new script that we can use to drive our stars. So on scripts, I'll simply right-click, come down to Add, a new item, And then using our template, let's come over here and call this guy stars, like such. Now from inside of stars, there's a couple of things that we're going to need. First of all, a speed. And I'll go ahead and set this guy to public. That way, if we want, we can tinker around with the speed externally or over in the inspector. So let's open up fields and come in here with a public and then float speed. And yeah, that's good enough. So if I save and jump back over here, let's take this new script. So come down here, there's stars. And I'm just going to simply drag and drop him up on the stars plane that we created. There's our speed over here. So let's go ahead and start this guy off with a value of, I don't know, we'll just start with a value of 1. Now, let's jump back into Visual Studio, and it's time to get this plane moving downward. This is going to allow us to talk about something else that's quite interesting. One of the reasons I wanted to put this in here. Let's go ahead and kill out start. We don't need it. Inside of update, let's stick with the amount to move variable. So
the same thing we were using on the enemies?
You got it. Amount to move equals. Now we've got the speed, so let's just take speed and multiply him by, you know it, Zach, what is it?
Time.delta time.
You got it. Time.delta time.
See, I'd have gone over to the enemy and copy-pasted.
Yeah, of course.
But I'm lazy.
So next thing I want to do is go ahead and move this guy. So I'm going to do a transform dot. Now we're going to do a translate.
For relative motion.
And in the translate, so that we can do relative motion, we're going to tell it a vector 3 dot, in which direction we want to move them?
Down.
Down. So we'll go with down. And we'll take this, we'll multiply this by our amount to move. But we're going to find that things aren't going to move exactly the way we think they are. Let's go ahead and save this and then jump back over into Unity and hit play. It's moving. But which way is he moving? He is moving away from us.
Because you rotated it, so now it thinks that down is along the y-axis, so it's sliding away from us.
You got it.
I gotcha.
Because right now, anytime we do some sort of translation back over here, we're going to be working in the object's local space.
Yeah.
And since we have rotated the object, its idea of now has been shifted such that we've rotated Y from straight up towards us, pointing towards the camera, which means down goes away from us.
It's kind of that whole enemy's gate is down mentality.
You got it.
We've decided that Unity is a Y up world, so downward is always negative Y. Except we've rotated the plane, so now negative Y technically slides it away from us.
That's right. So to fix this, it's very easy. All we need to do is come into our translate function, and by putting a comma in there, you can see space relative to show up.
Nice.
All I need to do is say space dot. Are we wanting to move down in our own local space, which would be self, or world?
I've never heard it called self before. I'm so used to local.
True, but in this case,
but
local,
it works.
Yeah, local. It works really well since we're in code, and generally in code, when you're referring to an object in that code, you refer to it as this,
right?
And that's like self. So let's go ahead and set up world, save this guy, jump back over, hit play, and hey, look at that. We are now moving down. Now we're going to get to a point where this guy is going to go off the screen. And it is at that point,
goodbye.
Get numbers up here. It is at that point that we want for him to snap back up. So let's just get a quick, where do we want him to move down to? So down to, so just a little bit. So here we are at negative 6.3. Negative 6.3, negative 7.6 has us just off the screen. So yeah, negative, or 7.6, negative 10.76 that is. So let's go with negative 10.75. We'll say that that's going to be the point in which we're going right off the screen.
Okay, now it's when we're going to want to pop back up.
Yeah. So let's jump back over here. After we have translated or moved our plane down, next thing is going to be a simple check where I'm going to say if our transform dot, and then we're going to talk to the position, and we're going to talk to y is less than negative 10.75.
Now, is this still going to check in the world space?
This is going to, this is the real deal here, because you'll notice back over here when we were moving that even though it's been rotated, look what numbers are updating over here. It's
I gotcha.
Real y. It is the world space.
Okay.
So jumping back in here. So if we get less than that, Well, where are we starting out right now? We're starting out at a value of 1. So for now, how about we just reset it to 1? So jump back over here, and we'll simply tell it that if it is indeed gone less than negative 10.75, that we are going to set up a transform position, new vector 3, and let's just stick with our transform position.x. For y, let's just go with 1, and then finally for z, we'll just keep z. Save this guy, jump back over, and play. So we're going down, and we've died. And I guess I could dodge, so, since the game could actually be lost now. Woo! So when he gets all the way to the bottom, boom.
Pops
right back up, fills out the entire screen, looks great.
Gotcha.
So with that in place, let's go ahead and get our second plane in. So with this guy, I'm going to, let's come up here to stars. I'm simply going to hit Control D. So I now have 2. And with one of these guys, I need to move him up. So moving him up in the world, a little bit higher, and
it's going to kind of boom, butt them right against each other.
It looks like 14 will do the trick quite nicely. And it does. Now look at this. If I hit play right now, they're both moving. Because we duplicated the guy that had the script on it.
So they both have the script.
They both have the script.
Now, are they both going to jump to position 1 when you're done?
They are. When each one is done.
Yeah, when each one hits its
That's
its
right.
point.
So 1 is no longer where we would want it to go back to.
We needed to jump to further north than the top of the screen.
And so we have that number already. We want it to jump where this guy is right now.
Yeah.
So this guy is at a value of 14. Let's just come over here.
Change our value to 14.
Let's just change the value to 14.
We kind of get that conveyor belt effect.
We'll save it. And I'll leave, let's select this guy right here so everybody can watch what's happening. So we know we are indeed scrolling down, but watch what happens when we hit that magical point. So down,
There, and then
and pop.
Very nice.
So that's it.
Down here in the game screen, you notice no changes.
Nope.
Yeah, it's just a solid white sheet. So I guess now it'd really just be applying the stars to it. Cool.
So and here comes the other guy, and pop. So applying the stars, very simple. Since both of these planes are using the same material, with either one selected, I can just come over here and grab stars, drag and drop, and I got stars all the way around.
Nice.
So let's go ahead and just save real quick, hit play, and take a look. Actually, just so we're staring only at our play screen. There we go.
Nice.
Well, I guess I could move out of the way. A little slow there. But as you can see, we are now scrolling. Looks good.
So now we have space balls versus space boxes.
Yep.
Space balls.
Pretty straightforward, eh?
Yeah, real nice. I like the system. Easy to understand.
It's very, very easy to put together. I had another student. I'll take just a second to mention him. It goes by the username MacMag over on 3DBuzz. That was working with me. He's learning Unity. And he did a very interesting thing when tackling stars. He used a cylinder.
Yeah.
And then he mapped the stars to that,
it.
and then he animated it rotating.
Yeah, I was just thinking about that a second ago. You do it like a big odometer.
Yeah, and it looked great.
Yeah.
And if you wanted to, you could dupe that off and get a transparent material on there.
Seems like a lot more polygons.
And you're definitely dealing with more. But I mean, come on, polygons are not going to kill us
Sure.
with a game this simple. But still, I thought it was very creative.
Yeah, absolutely.
Wow, that's cool. Okay, so now that we have this set up, let me think. Is anything else? Just, of course, a quick reminder. Setting your speeds. Now, both of these guys are referring to their own instance of the stars class, which means if I set the speed on one of these guys, and then let me go ahead and scroll back around here and hit play, we're going to have some separation, as you can see here. So, and to make it a little easier to see, let's go ahead and turn this off and hit play again and jump over. So make sure you keep your speeds at the same.
Right.
Make sure you keep them consistent with one another. So let's go with maybe something a little faster than what we had before, 1.25 and 1.25. So any questions, Zach?
I don't suppose you can do like a public static so that you could actually talk to the class on both those.
Yes, absolutely. The only thing to keep in mind is you're going to lose it over here in the thing. But I mean,
gotcha.
it does work well. If I was creating this as a real game that I was going to be distributing, I may use the inspector from time to time just to go in and play with values and watch and find a value that I like. But you don't see me creating, and this is just the way I like to work, you don't see me creating public fields that are going to show up in the inspector and for me to leave them there.
Is there more overhead?
No, we start to get into design practices. The concept of working with object-oriented files is you want everything to be private. You only want to expose things through properties. And that's something that we're going to be taking a very close look at when we do the next implementation of this game, and we're going to put a lot more structure in it, but it's going to be set up in a way that you can work with a large team of people and you can work with the ease, and you don't have to worry about things getting broke with linkage and stuff like that. Where here you already see we're linking things up.
Yeah.
And if somebody came in here and changed the name of one of those, like the background texture one, change that name, save it out, it's no longer linked to the texture, and now we've just broke something. And we want to try to prevent cases like that. That's not to say that an individual coming in and coding can't, rapid prototype a game by just, tossing up things, public things that are going to show up in the inspector and then linking things all over the place. That's not a problem. It's just when you start getting into complex linkage and you're really no longer prototyping, but you're actually working towards a final game, then you may want to consider a different approach for coding. But anyways, with that, to answer your question, absolutely. Just come in here and do a public static float speed, and then when you refer to speed, just down here, just simply say stars.speed and set your value in here. So it'd be public static float speed equals 1.25,
whatever you needed it to be,
and then you've got one place to change it. Because you're right. I don't like the idea of having to change something in multiple places, and if you forget, you break something. So I would definitely not take that approach. But for this video, again, keeping things super simple, very small script with what we're doing, very simple system to implement, and in the end, very effective because you get the sense of flying through space. So with that, that is going to wrap up this video. Thanks a lot, guys.